Hi everybody, this is Miss Shing and Miss Padmini with the admirable help of Mr. Stephen, and we're going to talk about another fact family for 10. This time we need to know about something called digit, which is the number that is a digit can go from 0 all the way to 9. It can be 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. But a digit cannot be 10 because to write the number 10, you need two separate numerals, a 1 and a 0. And a digit can have only one numeral. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 are digits. Do you dig it? And when we give out these 10, guess what, cookies to our two kids, each of them can only get a digit of cookies. It cannot get 10. It can get 0 all the way through 9, but not 10. So we're going to give out these 10 cookies to these two kids, and we're going to start with, why don't we give one kid as many as we can? Okay? Can we give the kid 1? Yes. Let's give 1, 2, 3, 4, 5, 6, 7, 8, 9. Now the next one would be 10. Can we give 10? No, because 10 is not a single digit. So that last cookie has to go to the other kid. So to give out these 10 cookies, kid 1 has 9, kid 2 has 1. You might think that that's not fair, but it's going to change eventually. So let's write down our 10 fact. There's the number 10. You can divide the 10 as 9 and 1. So how many cookies altogether? 10. Kid 1 has 9. Kid 2 has 1. Now, let's go ahead and write it out. Let's put down that 9 plus 1 equals 10. Let's move a cookie. Let's move a cookie over, and we now have kid 1 has 8 cookies. Kid 2 has 2 cookies. Let's write down our 10 fact of 8 cookies for kid 1 plus 2 cookies for kid 2. And the total is still 10. Okay? Let's continue down the path and move one more cookie. And now you have 7 cookies for kid 1, 3 for kid 2, and 7 plus 3 equals still the same total. It's going to be 7 plus 3 is 10. Let's keep distributing those cookies. One more over to kid number 2, and we have how many for kid 1? 6 cookies and 4 cookies for kid 2. So 6 plus 4 equals 10. Okay, one more move. Let's move one more cookie over. I wonder if this time they're going to be equal to each other. The first kid has how many cookies? 5 cookies. Kid 2 has how many cookies? 5 cookies. Total is still 10. Let's write it down. 5 plus 5 equals 10. Now, we're going to do a little more moving, but this time we won't write down the facts. Let's move one more cookie over to kid 2. This time, kid 1 has 4, kid 2 has 6, which is the same as if kid 1 had 6 and kid 2 has 4, which you can see. Kid 1 has 6, kid 2 has 4, total is 10. And if kid 1 had the 4 and the kid 2 had the 6, guess what? It would still be the total of 10 cookies. So we won't write it down again. It's 6 plus 4 equals 10. 4 plus 6 equals 10. Some people call that commutative property. Can you say commutative property? Now let's move one more cookie. You have 3 for the first kid, 7 for the second kid. Where does it show up where 7 and 3 occur? Ah, there you have it. 7 for the first kid, 3 for the second kid is 10. And 3 for the first and 7 for the second is also 10 because of, as you know, commutative property. Let's move one more. And you have 2 and 8. And on the board you have 8 and 2. And let's move one more. And we have 1 for the first kid and 9 for the second kid. And it is the same as 9 for the first kid and 1 for the second kid. And the total is 10. Now, can we move one more cookie to kid number 2? If we're working with digits, the highest number you can have for anybody is 9. So we cannot move one more cookie over. That's all of the ways you can divide up 10 cookies between 2 kids. 9 and 1 or 1 and 9. 8 and 2 or 2 and 8. 7 and 3 or 3 and 7. 6 and 4 or 4 and 6. Or 5 and 5, which even if you switch them, it's still 5 and 5. Thank you very much, everybody. This is Ms. Shing and Ms. Padmini with the admirable help of Mr. Stephen, and that was your teachable moment.